Okay, I thought I'd do a real quick video summary of what we did in class today so that if you ran into problems on the homework, you might be able to refer to this to set up the homework problem. In class, we looked at the catering business and we looked at two trucking companies that were going to carry the food for the catering business. And we had a trucking company called Peter's Pickup, and they charged a flat fee of $68, and then after the $68, it looks like they charged 40 cents every mile. That's our rate of change. And we have Helen's Service, which ran a flat rate of $23 to come and pick up the food, and then for every mile after that, they charged 65 cents. And we wanted to do an analysis to see which company was going to be the cheaper, and it gave us some questions, but I think what we'll do is we'll just run through how to set this thing up. So we have two linear relationships. We have a starting point and a rate of change. I'm going to use y of p to represent Peter's cost, or the cost of using Peter's delivery service. We see that what we're trying to do here is we're trying to figure out cost that's dependent on mileage. So cost is our dependent or y variable, and how many miles we drive is going to be our independent variable. The cost depends on how many miles we drive. So our cost in the first case is dependent upon miles, and it's going to be 40 cents for every mile we drive plus $68. In the second case, Helen's cost is going to be 65 cents for every mile we drive, and there's no rhyme or reason to the fact that I'm leaving out the zeros, but 65x plus 23. Then we set these equal to each other using the substitution method that we've been studying, and eventually we were able to take a look at the fact that when we solve these equations simultaneously, we found out that at 180 miles, I believe that both of them cost, let me figure this out, at 180 miles, we figured out in class that they both cost, I can use either one of these obviously, enter plus, I think it was 140, plus 68, 160 plus 68, no, it's going to be 72 plus 68, right? 140, that's what I thought. So, the cost for his deliveries at 180 miles is $140. Once we solved them simultaneously, you got X. The cost for this delivery for Helen was $140. And then we took a look at what happened if you have a delivery distance that's more or less than, and I think here we came up with 40 and 68 would give us 108. And we put 100 miles into here, and we came up with 65, and 23 came up with 88. If we put 200 miles in for X, the service that Peter is running would be 148. And the service that Helen is running would be 153. So we see at 180 miles, they both cost the same. At 100 miles, Helen's service is cheaper, and at 200 miles, Peter's service is cheaper. And remember, the way that we solved for X was we used our substitution method for these two, and we set 0.40x plus 68 equal to 0.65x plus 23, we solve this entire relationship for x by moving all the x's to one side and the numbers to the other. Then we took that value and put it back in and calculated a y. So now we can see exactly what the data tells us as far as which service to use depending upon how many miles we drive. I'll go ahead and solve this in case this is where you run into a problem. I will subtract 0.65x from both sides here. And I will get negative 0.25x plus 68 equals 23. If I subtract 68 from both sides, I should get negative 0.25x equals 45. I ended up solving that. That's where our 180 came from. I put that 180 back into here to get Helen's cost, put that 180 back into here to get Peter's cost, and then I threw these in just to see what happened at a mileage less than 100 and a mileage, less than 180 and a mileage more than 180. So that's the approach you're going to take for the problem number 2 that you have to work on for homework.